Hey, welcome to another lecture. In this lecture, we're going to talk about Python exceptions. Well, what is an exception? It's actually an event which occurs during the execution of a program that disrupts the normal flow of the program. It allows us to be able to handle situations that are not expected or not ideal in executing a program. We'll look at some basic exceptions and how to handle them. Exceptions can become an advanced topic, so we'll just try to focus on what we need to know, the basics in this course. Of course, feel free to read the Python docs about exceptions or look at some of the books. There's several different things that can be talked about with exceptions, so I'm just going to try to focus on the basics. So, for example, let's look at something that we've seen before where we're trying to take a string, 10 as a string, and convert it to an integer. And we can do that with using just int, left parenthesis, the string 10, and then right parenthesis. That will return a 10. But the 10, of course, could have come from user input, or it could come from some other location. What happens, though, if we pass in something that's not valid? Well, in this example, how do you convert ABC, the string ABC, equal to an integer? Well, that's pretty much impossible. We don't know what that value should be. And so what Python does is it complains. It creates an exception, actually a value error exception, and produces the following output. In other words, it says it cannot convert this, doesn't know how to convert it to an integer. That's pretty much what this error is saying. Now, we can handle or catch these errors by using a try except statement. So the try syntax looks like this. You have try, and then you have some body of code, and then except, and then the except body, which the except body is how to handle it. Sometimes maybe you want to go with the default. If you ask somebody to enter in a value and they keep entering it, or they enter in an invalid value, maybe you specify a default, maybe 0, for example. It's really up to you what that is, depending on the code that you're writing. So let's look at an example. So let's look at kind of the example that we talked about before. So instead of, whenever we try to pass an invalid string, we'll try to pass a string to int. If it's valid, the except isn't going to get executed. The only time the except body here gets executed is whenever there's a problem. If there's a value error, for example. And then instead of getting the output that we showed up here, this trace back, we'll get a prettier message, or a nicer message, a more user-friendly message that says error ABC cannot be converted to an integer. Now, isn't this much nicer, much more user-friendly to have this error versus all of this traceback? File standard in line 1 in module, value error, invalid literal for int with base 10 ABC. What does that even mean? Well, for a programmer, somebody's using Python, they'll figure out what that means. You'll get used to that. But since quite often the users of our programs are not programmers, they're just users, something like this might make a little bit more sense. Even though there's still some jargon there, it still makes a lot more sense. So here's a little bit better of an example. Here's where we ask the user for an integer, we put it in a variable called res, and then we try to we try to convert that string, because remember, the input function here always returns a string. So whatever they enter in goes into res, and that's going to be a string. And then we want to take whatever string is in res and try to convert it to an integer. So int will try to do that in this try statement here. And if it's valid, if it's able to do it, it just jumps down below the try except and keeps executing code. If not, if there's a problem, we get this message that says sorry, the variable res, whatever it is, whatever that value is, cannot be converted into an integer. This is actually a classic example that you'll see a lot in Python programs. That's one reason why I was debating if I wanted to include the exceptions in this class. But the more I thought about it, I thought, you know what? You look at almost any piece of Python code or something that's a little bit complex, you're going to have a try except. There's going to be something going on. And so I want you guys to at least be familiar with the statement, have a general idea of what happens. So what I would like for you to do is to take these examples, copy and paste them into Thony and see what happens. Maybe do this one here too. Try different values for an integer and see what happens. You know, put in some values that you know is valid, like 10, 20, -5. And then maybe try whenever they ask for an integer, maybe type in your name. So I would type in Billy, press enter. Well, then I would get an error that says, sorry, Billy cannot be converted into an integer. So try that. Now, that's the best way you're going to learn is look at examples, try to understand what they do. If you want to be a programmer, you got to be willing to do that. You got to be curious about code that you see and go, well, gee, I wonder what that does and how that would perform if I change this or move things around a little bit. Let's look at a different example. Here's an example that raises an exception because we're actually dividing by 0. If you just put this out there without the try except, you would have num equals, well, I got these backwards, don't I? It should be numerator over the denominator. I'll have to change that in my notes. Now, I don't know why I haven't seen that until now, but 0 over 10 is valid. So this would not give us an error, but the numerator divided by the denominator will. So probably by the time you're looking at these notes, this will be fixed, this will be changed, but this is another little error that I have here. So it should be numerator divided by denominator. And if you copy and paste all of this code into Thony or a different Python editor and execute it, you should get an error. It should print out error, cannot divide by 0. And if you just do this, if you just copy and paste num is equal to numerator divided by denominator, you should get a really nasty message. Like, so for example, here in Thony, if I do 0 divided by 10, 10 divided by 0, I get a 0 division error, division by 0. And so my try except here will catch that error and will output a better error. Now, actually what the try does in this situation is it will catch all of the exceptions and will output this error. And that's not necessarily what we want to do. There's times that based on the type of exception, remember up above with the int problem we were looking at, what was the type of exception we got? We got value error. What was the one that we got whenever we did the divide by 0? It was 0 division error. So these are different types of exceptions. So you can actually have a try and then say except and then a certain exception type and then have a body that deals with that exception type. And you can have more than one of those if you need to, based on the type of exception. So here I've got an example. This is something else I need to fix. But we get an error. We have a try numerator over denominator except 0 division error. Then we print out numerator is 0. Now let's look at at a variable that doesn't even exist. Let's just create a variable called myVar, just something new that we've never seen before, and we do this statement here. I'm going to copy and paste that into Thony. And actually there's an indent error, which is something different. For some reason, it didn't copy and paste it right. So let me try to fix that. And the way I do that, just indent the stuff a little better. Notice what happens here. Value cannot be converted to an integer. So it tries this code, it comes up with an exception, and it just prints this out. Well, what's myVar? It doesn't exist, is what it's saying. MyVar is not defined. Actually, the exception is a name error. So really what we need to do here is change this so it is something like this. Try int myVar. Is it not going to let me do that? I'm trying to. Well, I may have to copy and paste it somewhere else. Let me do it up here. Let me create and then I can copy and paste it. So the code I want to write is something that looks like this. Try int myVar except, and then I had the print statement. Print, see what it said. Value cannot be converted to an integer. So we can copy and paste that down here, and we should get the same error that we just got a minute ago. Value cannot be converted to an integer. Well, myVar, as remember, doesn't even exist. So really, to fix this up here, remember before, whenever we try to convert a string to an integer, we get a value error. So let's see what happens whenever we execute this code. Notice now we get the same error that we got up here whenever we just try to reference myVar. So what happens is we try to execute this code. Since the error that we're receiving is not a value error, it just skips over this and we get a normal name error. Now, what we could do in here as well is we could say name error and then put print. Actually, that's not what we do. We do this. MyVar does not exist. Until we get a prettier error. Let's see if that's really what happens. So let's copy and paste this. We can take it down here. Notice that that's a little bit nicer of an error. So we have a try int myVar. Since it does cause a name error, it would then execute this print statement and then execute completely out of the try except. We could also go further then and just say we could mask any type of error that we got from this int by just saying don't know what went wrong. And what that would do then is print out don't know what went wrong anytime that we got an error that isn't a name error or a value error. If you read in the notes here, and I've kind of gone off track a little bit, but it is good to go through here and read these, but I pretty much do the exact same thing. If you want to catch the error and you don't know what type of exception it is, you can do it this way. It's not indenting it properly whenever I do a copy and paste, but that's okay. It probably isn't going to do it for you either, so you may have to take the code and move it over and then do some indentation yourself, which that's okay because this is a good exercise in learning how to indent Python code. So here we go. Take this, copy, paste it here. And what I need to do, I messed up. What I need to do is, it's a lot easier just to keep these here on the end like this. I'll just move these over too, just make it look a little prettier. There we go. Now if I copy and paste, and now it says something went wrong, exception name, my var is not defined. So that is much better than what I had up here when it says don't know what went wrong, that I had up here with the except. By putting this exception as ERR, you're saying take whatever exception we got, put it in this variable ERR, and then we can reference it down here in the exception body and reference it right here to output this message. So this is a little bit cleaner than what we had up here with the, which whenever this was, yeah, this one here. You could actually customize the errors a little bit more to where it's not as hard to read. You could actually give some feedback. So that's pretty much it, I believe, with exceptions. You can look at a full list of built-in exceptions at this URL. There'll be a link in the notes, in the lecture notes. You can click on that. You can read to your heart's content and learn as much about exceptions as you want. Like I said at the beginning of the lecture, this is only an introduction to exceptions. So you're not an exception expert, but at least you're aware of them. And whenever you come across one in some code, you at least have a general idea of what they do. So that's it for this lecture. I will see you next time.